Good day, everyone. Welcome to my channel. I trust we are all doing great. We are on integration by method of substitution, and the last time I said integration by method of substitution, we substitute for a term and we replace the term with another term to simplify the expression and resolve. And also, I gave 2 hints the last time. In the last example I solved, this is the second exercise 2. So in exercise 1, I said you substitute for the y or the f of x, and also the dy dx or f prime of x should be in the numerator. So to start with, now in the last example I solved, I'll be making reference to that example in solving this example. So we have the example here, and this is the question here. We have integrating 2s cos s raised power 2, and here I said substitute for the y or f of x. Here I substituted for x squared because x squared seems like the y, like a y, and this looks like the dy dx. And also, when I was talking the last time, I said we used method of substitution especially when we have something like a function and its derivative in the integrand. This is the integrand, the expression we want to integrate. So this looks like a function and this looks like its derivative. In that expression, we used method of substitution. The method of substitution is like the chain rule of differentiation. The method of substitution in integration is like the chain rule of differentiation. So I substituted for the one that looks like the y, and so here when I come here now, this is the question we have to solve. Now, which one looks like the y? When we differentiate sine, we get cos. When we differentiate cos, we get sine. So this is sine cos, this is sine cos, this is sine cos. So how do I know the one that looks like the y and dy ds? So it is not easy to determine the derivative or the function by just inspection. So now I go to the second hint, which says the dy ds or f prime of s should be in the numerator. Now this is the numerator. So if I take this as the numerator, then I will take this, let me take this as the dy ds, then I will take this as the y, the function. So I will substitute for this. Now let me get started. Now we have integrating by method of substitution. In the end of the observation, we substitute for a term. So I will say let u, this is dy ds, the numerator, then I will take this equals to sine x minus cos x. Let me take this as 1 because I'm defining another function, another variable u. So I will say du dx equals to cos x. When we differentiate sine x, we get cos x. Then we have minus here, then we have minus sine x. When we differentiate cos s, we get minus sine s. Then here we have cos x, then we have plus sine x, then ds. Now I want to get the expression for ds. When we integrate, let's substitute this and this. So this and this. So we have dx equals to du over, then I can also say sine x plus cos x. Right? Let me take this as equation 2. Then let me substitute for this and this in this initial expression. Now we have substituting for u and dx. So let's go back to the initial expression. We have integrating, we have sine x plus cos x, then we have over sine x minus cos x, then we have dx. Then this gives us, now I can write my sine x plus cos x. Then instead of writing this, remember we have said let this be equal to u. So I will write u. So ds, we are substituting for ds also. So we have du over sine x plus cos x. So we have two equations, u and ds. So we are substituting both in this expression. So this is sine x plus cos x, this is sine x plus cos x. So it cancels out. We have du over u. And also, how do we integrate this? According to the standard integrals we did in our last class, we have that, okay, here it is, integrating 1 over x will give us ln x plus c. Then if that is the case, integrating 1 over u will give me ln u plus c. Now, what is u? Recall from equation 1 that u equals to sine x minus cos x. This is equation 1. So I will substitute for u. So I have ln sine x minus cos x plus c. C is the constant of integration. So that's all. So I can say therefore the integral of sine x plus cos x over sine x minus cos x equals to ln sine x minus cos x plus c. So, and that's final answer. Thanks very much for watching. See you again next time. Have a blessed day ahead.